Sorry. Again. Let's try more. I've got a couple more of these figured out. F of x equals 3x squared plus 2x, and we are going to find the limit as x approaches -1 of 3x squared plus 2x. Again, to get the limit, all we do is substitute in, get the y value. So it's 3 times -1 squared plus 2 is 1, 3, 5. The tough part, prove it. So you start with your original problem, then use the properties to break it apart. The limit as x approaches -1 of 3x squared plus 2. Okay, the first property we are going to use, and usually it's the first property all the time, is the limit of a sum. So applying the limit of a sum, we'll get the limit as x approaches -1 of 3x squared plus the limit as x approaches -1 of the constant 2. So I can get rid of that too. Okay, this one's ready to go. This is limit of a constant is equal to the constant. That's this one right here. Limit of the constant function equals the constant. So limit of the constant function just simplifies down to 2. Here, I need to pull the 3 out in front. So that is the limit of constant times the function. That's my abbreviation for that. So that allows me to pull the 3 out in front only. Nowhere in there do we have the limit of x squared. I have to be able to break this apart. Need a plus sign in the middle here. What we can do is think of x squared as x times x and use limits of a product. So the 3 will carry along, and the limit of x squared becomes the limit as x approaches -1 of x times the limit as x approaches -1 of x. So I took the limit of x squared and broke it up into the limit of x times the limit of x. And I still have my plus 2. Now both of these match the identity function. Limit of x equals that constant that I'm approaching, c value. So that's the identity. So both of these are limit of identity. So the 3 carries along. The identity function equals the x value that you are approaching times -1 plus the 2. And there we've got 5. Not too bad. And let's challenge you with one more. Okay. F of x equals 2x squared plus 7x minus 15 over x plus 5. First part, we're going to find the limit as x approaches, you probably could guess, -5. So if we put -5 in there of f of x, we will have 2 times negative 5 squared plus 7 times negative 5 minus 15 all over negative 5 plus 5. And here we were going to get 2050 minus 35 minus 15. I think we get 0 over 0, which tells us we're going to have to factor. So if I go back to the original, you know one of the factors is x plus 5. The other one you can figure out fairly easily because the first times the first has to give you the 2x squared. And then the last times the last has to give you that a negative 15, so we need a minus 3 in here. So when we cancel out, those will be gone. So we know that it should be 2x minus 3, plugging in the negative 5. Let's see, negative 13. And we could graph it to see if you wanted to, but I don't want to take the time. Now the proof. Okay. So we go back to our original problem. Limit as x approaches negative 5 of 2x squared plus 7x minus 15 over x plus 5. Okay, again, first thing you want to do here is break this apart, and I think we want to break apart numerator and denominator. So that is the limit of a quotient. So we'll have limit as x approaches negative 5 of 2x squared plus 7x minus 15 divided by the limit as x approaches negative 5 of x plus 5. Now you know for us to get that limit up there we had to do some factoring. You're going to want to follow the same steps here. I'm just going to go horizontally here and do just some algebra of factoring this numerator part. So we've got the limit. I'm not going to use a limit property at all. I'm just going to rewrite that quadratic in factored form. And we know that the two factors are 2x minus 3 and x plus 5 over the limit as x approaches negative 5 of x plus 5. Very tempting to want to cross those off right now, but this bottom is the limit as x approaches negative 5 of just this. Up here, this doesn't have its own limit yet. So that's where we want to go next, is to break this apart to the limit of the two multiplied here. Our next step is going to be to, just to the numerator, apply limit of a product. So the numerator is going to become the limit as x approaches negative 5 of 2x minus 3 times the limit of x plus 5 as x approaches negative 5. The bottom hasn't changed. The limit as x approaches negative 5 of x plus 5. Now by algebra, I can cancel those out. So algebra lets me cancel those out, and all I have left is the limit as x approaches negative 5 of 2x minus 3. Ooh, we're almost there. Now it's just a simple problem, just like example 1, but it took us a little while to get there. Break this apart using limit of a sum. Sum lets me break that up into the limit as x approaches negative 5 of 2x plus the limit as x approaches negative 5 of negative 3. This one's ready to go with limit of a constant. I've got 2 steps left here. I've got to pull the 2 out in front with limit of a constant times a function. So that's 2 times the limit of x as x approaches -5. This term is ready to go. Limit of a constant. I know I totally ran out of room here, but that just goes to -3. And this one, limit of identity, takes me to 2. Limit of the identity says that equals the -5 plus the -3, and there we proved it, -13. Whew, we made it. That's it for the day. I gotta find the assignment. I'm gonna try the pause again. Okay, homework assignment is going to start on page 49. We're going to pick up quickies 1 through 5. Then on homework problems, we are looking at 7 through 12. This is on page 50. And number 22. That's it.